Question number 21. In this question, all diagrams are drawn to scale part of the emission spectrum of the atom is shown. A very similar question. Many times we solve such kinds of questions. Anyway, we solve this. Which set of energy levels can give rise to this part of this emission spectrum? Okay, now what you can see is this increasing wavelength. No values are given, but somewhere your logical reasoning skills are very essential to solve such problems. So we'll mark this by some wavelength notation. I'll call this as lambda 1, this is lambda 2, lambda 3, lambda 4, lambda 5, and lambda 6. Okay, now you see these two is a doublet. Doublet means what? Two wavelengths are very close. Okay, how close are they? Maybe let us say, for example, this could be something like around 5800, and this could be 5810, right? This could be so much small or so much narrow over here. Similarly, if I take something like this here, maybe let us say this is 6200 and 6210. You can always ask me why 6200, why can't it be that? You can take, okay, you can take anything, but I am just putting some values. Okay, you can put even 5000 here, and you can put 4000 here. But only thing is it should be increasing thoroughly, so I am putting some values like this could be, let us say, for example, 7000 here. This could be something like 5000. Okay, you can put 4000 also, but anyway, I'm putting it like so. So now, when we know when the wavelengths are nearby over here, the energy is given by hc by lambda. So which means if this value changes by 10 units, okay, see here, this energy level and this energy level will also change only by a very small amount. Maybe this energy level, the first energy level here, could be something like, let us say, 13 points. So what you are using, right? Okay. Let me say, for example, this energy level could be something like 10.2 electron volt. The second one could be something like a 10.22 electron volt. Okay, very small difference over there could be seen. Okay, it cannot exceed more than that, right? So this is what you call as a doublet. What you call as a doublet. So there are two doublets being seen. Now we need to map this doublets even in the energy level. How do I do this? First, let us look at this. So why do we get these number of lines? See, an electron just present over here will jump here, will jump here. Now let me call this energy as E1. Let me call this energy as E2. Now how will these energies be related? Will they be very closer to each other? Will they be farther away? They will definitely be closer to each other because E1 and E2, you say, okay, so it is different. The difference between these two is very small. So definitely E1 and E2 would be a doublet. I call this as one doublet. Similarly, there could be an electron over here. There could be an electron which could jump here, Can this be a doublet? This cannot be a doublet. Why? Because this energy can be something, let us say 1.4 something. This could be much more larger. See, the energy gaps are larger over here. See, the energy gaps are smaller over here. Okay? So this almost seems to be overlapping. So therefore, here you get one doublet here. And do we get any other doublet? Let us take, for example, we'll take one more electron here. It jumps from here to here. It jumps from here to here. Now we will have this energy as some energy. Okay, let me say E3, and this energy as E4. Now will E3 and E4 be close enough to each other? Yes, definitely. Because let us say, for example, this energy could be something like around 10.4 electron volt. This energy could be around 10.35 electron volt, and this could be around 13.6 electron volt. Yeah, minus here, it is minus everywhere over here. So what can happen? The difference between these two and difference between these two will be very, very small, right? So sorry, difference here is larger, but the delta is for each one of these levels is smaller. So probably you might get one more doublet over here. You get a doublet here, you get a doublet here. Nowhere you get it. So let me say this is the right answer. But we need to verify for the rest of them also. Let us verify for this also. Now an electron here. Okay, will now jump from here to here. One line from here to here. This definitely is a doublet. But you get one more also here. So this will become a triplet. Which means what? In the energy diagram, in the transition diagram, you should have got three lines which are closer to each other. Okay, but here you see there's a different distance between these two. So this is the right one. Okay, so here we don't get a doublet, we get a triplet over here. Here we get two doublets over here. Okay, so if you did not understand this particular part, do write me in your comments. So maybe I will take up a few more examples and describe about how do you get this one. Okay, and now let us take up this example also. So there's an electron here which jumps here. There's one more electron which jumps here. One more electron jumps here. Now what do you get here? See, the energy differences here are very close. So therefore, definitely this could be a triplet. Now let us take one more electron here. Okay, so this jumps here, this jumps here. So this could be one doublet possibility. There's already a triplet over here. Is there a triplet in our diagram? There is no triplet over here. But definitely this is also not possible. And this one, by the same reasoning, see for example, all the energy levels are equispaced, right? So therefore, so you will neither get a doublet nor a triplet. Everything will have the same energy level. Whether an electron jumps from here to here, or from here to here, or here it will be much larger over here, here it will be much larger over here. So therefore, every energy levels or every line would be equispaced. So you will never get something like a doublet or a triplet over. So thus, so the answer is A.